Hello, hello, Yankee. Can you hear me?
Yep.
Okay, all right. Okay, I can hear you. What's happening? Where are you?
Downstairs.
Okay, great. Trying out a new place. All right. Okay, I'm seeing your stand. Right. Cool.
Let me figure out to fit the camera.
Right. Okay. So let's see whether the light is enough, right? Okay. So might as well show you mine so you get some guidelines. Remember, you have to have this 90-degree, right? Are you having it?
Yeah.
Then you also need to flip this guy, right? So then the phone should be, so you're using your phone zoom, right? It's great.
Yeah.
I noticed that your phone zoom is on the portrait mode. So you just got to do this to make it enter landscape mode first. Make sure there's no rotation lock because the yeah, I think that's landscape mode. That's great. It's wonderful. Right. Then you just put it here, right? Just put it here. So the main camera should be jutting out here, right? The main camera. We're always using the main camera, not the selfie camera.
Yeah, great.
Right. So yeah, main camera. Main camera over here. Yeah, looking good, right? All right. Okay, it is looking good, and your right-hander or left-hander? Sorry.
All right.
Right-hander. So I suppose the base should be on the left side, so that will be the least disruptive. So the base on the left, and then I will be seeing your paper, which is great. And then you shouldn't attempt to show me the full paper. You should attempt to show me half the paper. So that means I want you to zoom in using your phone lah. Zoom in, and then maybe zoom in until the width of the something like that. So maybe slightly zooming up, just slightly up. That might make it easier. Right. Okay, something like that, right? Something like that. Now, show me a paper with your writing. So because what I want to see is your writing mainly, the other thing should be very easy for me to see, right? Yep, something like that, right? Okay. So your connection seems very good. And since your writing is a bit small, yeah, so let me see. Yeah, I believe I can see it quite clearly. That means your connection is good. So let's do this. Let's try this. If I'm having difficulty looking at your writing, that means I will ask you to zoom in more, but that would be actually less convenient for both of us. Okay, so may I know whether you have a laptop with you or not?
No, you said you need that.
Right. Let's give it a try. And if it is not working very well, then, on Wednesday, we'll do with a laptop, right? Now, are you using your data plan or are you using a Wi-Fi from the house?
I use data. That's no Wi-Fi
right.
downstairs.
Right. So for 1.5 hours, maybe data would be, what? Data would be, oh, you have another phone. So in case, I suppose in case I need to show my screen, which is currently not possible, right? Then maybe we'll use that phone instead, right? Okay. So, but the data plan will maybe at least half a gig lah, maybe for 1.5 hours at least. So that might be something. So in order for this to totally not, disturb you in any way, the height should be, be above your head. And then you compensate by zooming more. You compensate by zooming more. Above your head. So as you can tell, you cannot see it in front of me at all, right? You cannot see.
If I look out, I can see, but like, I guess.
Correct. Correct. You should be like sitting, naturally, as if the stand is not there. The light might be a bit blinding though, so you may want to adjust that. Not sure how that will go, right? Right. So again, just try and write something. Like let's take a pencil, write something, see whether it works for you. I see some shakiness, but I believe that's from the table. I believe, yeah.
Yeah.
So I want to see whether it's very shaky if you're writing. So that might matter. That might matter. Let's see. So yeah, I think we'll be spending a few minutes solving a technical problem. Yeah, definitely I am not okay. Yeah, definitely I need to zoom in a bit more. You do need to zoom in a bit more because I cannot. Yeah. Okay, that's a bit that's big. That's great. Okay, so I might ask you to shift from left to right from time to time. So because now I can see your writing more clearly. Okay, let me see if I'm reading it clearly or not. PCl3 and BF3. I'm having difficulty telling whether it is a 3 or a 5, right?
Yeah.
PCl3 and BF3 have simple molecular structures. Dot PCl3 has shaky, cannot read, dipole, permanent dipole. Yeah, I cannot read the word in front of dipole. What is that? What's that? PCl3 has permanent dipole. Oh, right. Okay, then interaction in this molecular bonding between PCl3 molecules. Wow, okay. Don't change your writing again. Don't change it for the sake of this. We'll just see how it goes, right? Okay, so that's for writing. For math, let's see what happened with math. So now, what is our priority right now? You are not having school until next week, right?
Yeah.
Okay, so how do I say this? Shall we jump immediately into it? No. We should do technical tests first. We should try one question. You choose any question, any subject. We should try that first because I think there'll be some problem. Okay. Don't jump right to it. So choose a question. Any subject, any topic, but it's a meaningful question. Don't make it a random question. Like maybe it's a topic that you want to know, or it's an upcoming topic. Those kind of things.
Yeah, sure.
Something meaningful. Yeah, I think we need to do some tests. So is the light? You're relying on the light from, right? Am I correct?
Yeah.
Is it bright enough?
I think so.
Is it annoying for your eyes because it must be in front of you?
Nah.
All right. Okay. Let's see what happened. Also in this mode, by right, we shouldn't mute at all. It will defeat the purpose. But you may choose to use either a headset or just use no headset. Either way works fine as long as you can hear it.
Okay. Looking for question.
Right. Anything meaningful, but don't take too long. Just doing technical test.
How about alkene?
Sure. Okay, will be fine. I suppose
Wait,
you do bring your
yeah, can.
lecture notes. Okay. Now, if you position your question, and I'm not reacting, that means it's not in my it's probably not in my view lah. So that might be what's happening, right? Because my view is currently quite zoomed in. If not, I cannot see anything.
Actually, let's try it.
I think it's fine. Let me get some water also. Again, I am in Batam. So in case I turn off my video, that must be the reason, because I think the connection will improve. Okay, so I am currently seeing your lecture note, but I'm not seeing the question at all. Okay, there you go. Right. Okay, so 13, right? Are you showing me 13? Is that what you want?
Yeah.
Okay, structure elucidation, a very fancy word, yeah, for arenes. Okay. So I have not been in touch with your chemistry until where is your lecture?
Arene, then I'll do periodicity. Well, I suppose like do periodicity in December holidays, so like studying it.
Right. So our connection is a bit bad, such that your audio is affected. So first, I'm going to try to turn off my video. Yeah. Okay. Now, am I sounding clear? Actually.
Yeah.
Are you using headset or as just direct?
Oh, headset. I can't like. I don't think I should.
Yeah, I don't think so, because then we'll be shouting. Okay. So that means just now was connection problem, right? Okay. So now, sorry, you're explaining your lecture is until I cannot hear actually. Just
periodic table.
What? Sorry. I thought you enter organic chem long ago. Huh? Sorry.
Yeah, we did.
Then how come it's until? Sorry, what does it mean by periodic table? Sorry.
Periodic table is like I think let me just show you.
Okay. Yeah, that's normal. Yeah, okay. Yeah, that's very normal. Yeah, those trends. But how come your lecture is here? Is this like this is the most recent lecture? Really?
Yeah, it's most recent.
This is not OChem lah.
No, OChem is after this. I think that's like I forgot what it's called. But there's I think there's an organic chem topic after this one.
So you're saying that sorry, yeah, you have entered alkene, right? You have, right?
Yeah, we finished alkene already.
So sorry, the two organic chem topic you finished is alkene and arene.
And alkenes and arene.
Sorry, alkane, arene. All right. So no alcohol, right? No carboxylic acid, ketones, all those stuff, right? But you're saying that after arene, you basically exit OChem and go to this periodic table.
Like one topic.
Oh, right. That's so weird. Okay. You ask your arene question. No, it's fine. You ask your arene question. So because I don't get it. Okay. The arene question just now was that thing. All right. So compound B. Okay. I am already having trouble reading the C8H10. Is it C8H10?
Yeah, C8H10.
So a bit difficulty there, but I don't think you should zoom in more, right? So, this must be the limitation of the camera. Oh, okay. I think we're hitting up. Okay. So how tall is your camera again?
Well, I mean, quite tall.
Like you're sitting right now, right? You're sitting right now. So is there any way for you to just lower the camera a bit without annoying you or without hitting your head, that kind of thing? Is it possible? See, it improves. So it is a camera problem. So now you can zoom out a bit, zoom out just a bit. Yeah. See, this is better than just now. basically the zoom is already making it worse. So by this, you're reducing the amount of zoom. Is it disturbing you? The stand?
It's all right.
All right. Okay. So let's see. So I'm just reading. Okay. So yes, the personal the misty fume of HCl, sure thing, right? Okay. Becomes yeah. Okay, sure thing, right? Okay. So your Ocam doesn't even, it's not even tested, right? Am I correct? Is it?
It was tested in was it? Wait, no, we'll have a test next week on alkanes and arenes.
Alkane and
Alkanes and alkenes. Sorry.
Oh yeah. No arenes, right? No arenes, right?
No.
So no problem. So now, so I must understand where you are because you don't have organic chem in O level. So I really have to see where you are first. Huh? So C8H10, can you tell immediately? Is it alkane? Is it alkene or I suppose then arene lah. Currently, that's the only three choice you have.
Arenes.
How do you know that?
Wait, let me think.
Yeah, don't look at the lecture note. You think.
Wait, so C8H10.
Yeah.
There's three on. Three on
Yes.
either side of the carbon. There's 6 already. 6 means there's 4 in the middle. 4 in the middle means that 4 in the middle means there's a double bond. So it's the alkene. It's definitely not alkane.
It's definitely not alkane. Okay, fine. Okay. Why is it not alkene?
I think it's either alkene or alkene.
Okay, and how do you, why is that? Why is it possible to be alkene or arene?
If it's alkene, then there's a double bond in the middle, right? So it's
right. The double bond is the sign of alkene, and then arene is, I mean,
arene is like arene is like it's in a kind of a circle. So
yeah.
it'll be connected to
I suppose you'll call it cyclical. I suppose that's how.
Yeah.
Cyclical. Now here's a few things. These are simple math, and that affects how you understand. So if it is alkane, which is it is not, it is confirmed going to be C8, right? H how many?
12.
No. It's 18. C8 H18. But how do I know that? How do I know that? Now, currently, because there's no laptop and there's no other Zoom, so I'm having trouble showing you, right? So instead, I want you to take your pencil. So draw here, draw here. Draw 8C. Just draw 4C. Okay, just draw 4C. Right. Okay. Right. Pencil, right? That's a pencil, right?
Yeah, pencil.
All right. So now you don't have to draw the H's. Okay. You don't have to. Just notice that every C should have 4 hands. Correct. Right. Right. So the way you draw the 4 hand, all the complete hands is that every C will have an up and a down. Correct. So would you kindly help me with the up and the down? So just a empty hand, empty hand up, and then empty hand down. Every C will do that, right? So please do that. Now your teacher might have said this, that if it is somehow, since we are doing a lot of shortcuts in the drawing, okay, empty hand can be considered to contain H, and that's all you're allowed to do the empty end. The others must have some symbol or something attached to it. But if it's empty, then it means that it is attaching itself to H. Okay, right? Okay, so you would notice that just like that, 4C will have 8 blank hands, right? So therefore 8 H's, simple, plus 2 more. How do we know? It is plus 2 more. You must still have plus 2 because obviously, if you look at it, the NC, you call it the terminal C, okay? The word terminal means the end, right?
Yeah.
Terminal C currently has 3 hands until you add the 4th hand, right? Whereas every other C in the middle will have 4 hands already. So that means they are satisfied. Okay?
Okay.
So that's why alkene has a formula which you should not, I believe you should not memorize. I think you should understand. The formula for alkene is the amount of C, let's say 4. The amount of H will be 2 times 4 plus 2. The times 2 should be obvious why. The plus 2 should be obvious why. I'm telling this from a visual point of view. Do you understand?
Okay.
So if it is C8 and you don't draw, because drawing takes time, if you can visualize better, if not, we draw. If we draw 8C just nicely straight like that, no need to be fancy, how many H's would you have? On the top, on the bottom, and left, right, correct? So how many? 18? Yes, precisely. 2 times 8 plus 2. That's why I say it's not 12. I'm very sure. Now, the other thing that you learn in alkane is that if you branch off, fancily, the H stays 18. That's one of the most important thing that you can understand about alkanes. Okay? The branching, the fancy stuff doesn't matter in terms of alkane. It will always be 18. So far, so good?
All right.
So now here's the thing about alkene. I still want you to understand it, not memorize it, because it's dangerous to memorize. The moment you put a double bond, right? So kindly put double bond in anywhere you like here. Here, just put a bond. How many hands must you take away? How many hands must you take away?
1 from each here.
Right, 1 from each. So please do that. Right, please do that. So whichever, like it can be the top one, it can be the bottom one. At this point, you should know that it doesn't matter too much right now, right? Right. So the formula for a simple alkene is the C8H18, right, minus 2 for each double bond. What I'm trying to say is if you put another double bond, please try putting another double bond. This will still be alkene and you will take away how many, right? You will take away another 2. You understand? Okay. The formula is not, it's not 8 times 2. It's not. It's, it's 18 minus 2 minus 2 minus 2, depending on how many double bonds you have. You can have more than 1 double bond. That's alkene, right? Okay. Now, for C8H10 to be alkene, that's what you're saying, right? It makes sense. It's less than 18, right? How many double bond must it have?
For C8H10 to be alkene, must have.
Right, 18 to 10, right? 18 to 10, so minus 8. Yeah, minus 8, how many double bonds?
4.
Yeah.
4?
Yeah, it's not 8, it's 4, right? Because visually, every time you put a double bond, you must remove 2, not 1. Okay, fair enough?
Yeah.
So C8H10, fairly speaking, can have 4 double bonds. There's enough space now. I mean, you have 7 spaces at the very least, you can say that, right? 7 space, then you can be an alkene. So whether it's arene or alkene will depend on, what is happening in this. The tutorial title arene is totally giving it away, right? Oh, this is arene, this is not alkene. But you shouldn't think like that in exam, right? No. You should think, however, like this. CHH10, they don't tell you it's arene, you should be able to guess immediately it's very likely to be arene than alkene, because I now challenge you to draw a C8H10 in the alkene, in the arene variation, if it is possible for you. Right? You can continue from here, you don't have to draw anyone, because remember, it's just cyclical. It's just cyclical. Right? Okay, that's 5C, right? That's 6C, that's 7C, right? So you probably have to erase that, right? Right, so that's the 8C. Now, kindly make the double bond, you need to connect, kindly make the double into single bond first, for now. Right, so single bond. Now, I'm not saying they are single bond, I'm testing you on your basic arene knowledge. You can look at your lecture note at this point, okay? Because do you know whether the cyclical stuff here, is it single bond? Is it double bond? Is there any row? Is there no row regarding arenes? what's the basic expectation here in Arins?
I think it can be either single or double.
You're not wrong. So this starts to form in a way that like what's the difference between now let's go in front first. So because I know you notice you flip the later part. Try to flip in the front part and the front part. Yeah, this orientation group thingy is definitely already at the last part of Erin. So you want to you go maybe forward a bit forward. Maybe you go to 1.1 maybe. Wait. Erin, oh, this is 1.1. I'm so sorry. Yeah, okay. So this C6H6, do you notice that is C6H6 is a very low amount of 6. H, low amount of H. Why?
Yeah.
Why?
I assume one carbon is bonded to one H.
But why? Why such a low amount of H? Like what happened to the hands of C? C has 4 hands. What happened to them? How come they only have 6 H's? If you cannot answer that, that's not a good start. We start from here. Why only 6?
Because it has double bonds on both.
All right. So I want you to draw that first. I want you to draw the 6C in a hexagon fashion, right? And then you figure out the double bond, single bond thingy. And then you count the H afterwards. Okay. That's 5C, that's not 6C. Your math is, your geometry should be better. No need to erase everything, no! Okay, never mind, yeah, just. Do you see me responding faster to, well, whatever you're writing? Do you feel that?
Yeah, I guess.
Are you also writing faster compared to the drawing book?
I mean, I'm using something I've been using for years. So.
Correct. And do you feel that this is just slightly more natural, I suppose?
Yeah, I guess. I mean, I'll have to find a way to stop the paper because right now I'm just writing on that. So.
Correct. The weakness here that there's a small amount of paper that you can write that I can see, I can follow, right? So let's see whether that disturbs us. Now, that's a wonderful hexagon. Now, if you think about this way, every C has 2 hands, right? Currently, is 2 hands are occupied for every C, correct? Every C is supposed to have 4 hands. You have to occupy all 4. Currently, every C has 2 hands occupied. Am I making any sense? You don't get what I'm saying.
Yeah, it does.
All right. Okay. So by right, there should be 2 more H's for every C, which is to say, I'm expecting C6H12, but that's not the case. You are right now to figure out how come benzene is C6H6, not C6H12. Why? Yeah? You need to figure it out. You need to. You can look at your lecture note for 1 minute only. You do need to figure it out. Yeah, you need to.
Let me think. So they each, if it's C6H6, that means all the carbon has to have 3 bonds taken up by connecting to each other. So
yeah,
here. So this will have 3.
So 3. So H1 only have 1, right? 1 already. So 1. So that kind of gives you some mystery, settle some mystery. Then you will notice that this 2C is all full. So you cannot actually have double bond next to them, right? You cannot, right? You can't.
Yeah.
Right. So then, however, if you wishes for another double bond, you can put it there. Yes, correct. So then this 2C.
Then this will have
HH, right? So we're solving some problem. And you will notice that there's only 1 more double bond here, right? Okay. Now, here's some good news and some bad news. The good news is you settle the H number mystery in some sense, right? You settle it. The bad news is that this is not the exact structure. It is interestingly smoother than this. That's the best way I can describe it. This is basically what they describe to you immediately in 1.1, this thing in front of you. This does tell me that you are not comfortable reading this even though we have been talking about this since semester 1, I believe. Back then, when you talk about orbitals, you will notice that those are pi orbitals, not p orbitals. Sorry, p orbitals. Sorry, p orbitals, not s orbitals, right? So the best thing we can have right now is our chemistry kit, which you didn't bring down, right?
No.
No problem. So next time you just bring up. Don't worry. I mean, we're just working on it. Now, you show me the below part of your note. Below part. Just go down. Just go down. Right. Okay. So no. He does not tell you why it is not like that. Flip again. Flip the page. He does not tell you why it is not. Does he tell you? No. Go down. Yeah, resonance. That. And I'm sorry. Go up. Resonance. Okay. So this word resonance, right? This word resonance. Resonance is telling you that for some reason he's telling you that it is not double bond and single bond, alternating. Because read number 1. Number 1 is all CC bond in benzene are equal and intermediate in length between single and double. So it is not double, it is not single. The length, the bond length of single and double is supposed to be different. And it is neither. Right? Okay. So you go down a bit. This this agrees with the description of benzene as a resonance hybrid, very fancy word, of two peculiar structure, which is again very fancy. He is telling you that some people think it is alternating between these two. Some people think. Okay. I think the explanation is simpler than this. So the second page is telling you that what you come out both makes sense and also disagree with what is happening experimentally when they measure the bond. Okay. Okay. So the best way to say this is that you draw the circle in the middle. You draw the circle in the middle. Right? So you draw a hexagon and a circle in the middle. That's how you usually represent the benzene, which is not your alternating double bond. The best way to describe this without the chemistry kit is it is 1.5 bond. The best way to describe it. So tomorrow, or rather on Wednesday, when you have the kit, you will, I believe, immediately understand. This on paper can be very confusing, or rather can be something like, I just accept what you're saying. Okay. But when you look at the kit on Wednesday, you should bring it down. I believe you will understand it immediately. Okay, that's the promise, right? Okay.
Okay.
Any questions so far? Right. Okay, now you go to the third page if you don't have, because we still haven't solved why is it. So how does C8H10 look like? We still haven't solved that. We still haven't solved it. So third page. Right. I'm sorry. The page after this. I'm sorry. I mean the page after. Okay. Yeah. Okay. So you go up a bit. Go up. Sorry. Go up a bit. I still can't see the. Okay. Right. There you go. So there's the word here, important word, cyclohexane, C6H12. Why is it C6H12? Why? You should now be able to guess why.
Well, because
just now C6H6, you solve it partially. Now it's C6H12. Why C6H12?
That's because
if you look at the picture, which is a hexagon only, right? That is a C6H12. Yeah, this is a
circle.
There's no circle. So again, what is it trying to say about cyclohexane? Again, so
it has only single bond. So it's
Yep.
just like,
Yeah. So every C, which is what you drawn first, right? Right.
Yeah.
So every C has two free hands. So the two free hands will have, we have two H's, so C6 H12. If you want to draw that for future reference, please do. Organic chem is very visual, at least at the start. Which one to draw it?
oh, gosh.
Now, what I gather from all this is that how did the lecture went? Like you watched the video? Is a direct lecture? What's happening in the
Yeah,
lecture?
I watched the video then
Right. So what I'm describing to you up to this point, okay, up to this point, don't you get it from the video?
I suppose. Mm. Yeah.
Because my impression is that either you're waiting for me to explain just so that you can be sure, it's a good thing, or you are not sure at all. I'm not sure which one were you just.
I suppose I'm just waiting for someone to confirm. I haven't done Avin since wow.
No worries, no worries. Glad to hear that the video makes some sense, right? Makes some sense. Okay, right. Okay, so cyclohexane, you draw that, so that's C6H12. In the left-hand side, before the plus H2, you see one with a single double bond, right? With a double bond, one, right? Right. So that should be C6H how many? Just for our guess. Yeah, should be C6H.
So minus
every double bond will take away how many H? So would you like to write down the chemical formula in case you feel that you need to be reminded? So that will be C6. No. Oh, okay. You need to draw. Okay, fine. You need to draw.
What do you mean by chemical formula?
Not the drawing formula, which is the structural formula they call it. I mean the simplest chemical. C6, how many H?
Huh? I don't get it.
The single double bond, is it C6H12?
This one?
Yeah.
This is C6H10, right?
Okay, sorry, I didn't hear it. So the one at the bottom, C6H?
This one?
Yeah.
C6H8.
Right. With all that, one last thing to notice, they call benzene, right? Benzene. They call cyclohexane. They are different, right? Benzene is C6H6. Cyclohexane is C6H12. This is bigger deal than what it might seem, but they do it until they give different names to it, right? Okay, so far so good. Yeah? So my question is, what is C8H10? Is it more similar to cyclohexane? Is it more similar to benzene? Or is it more similar to the guys in the middle?
C8H10.
Which is the one that we have in the question.
In the tutorial question.
Yep. Is it closer to benzene, closer to cyclohexane, or the guys in the middle?
I want to say benzene.
Which is, of course, benzene, it can only be C6, but let's imagine a benzene with C8, right? Let's imagine, which will have alternating double bonds, right? If that's the case, it will be C8, how many H? You can draw, you can figure it out, whatever you want. If it is a C8 benzene, how many H?
Let me think about this. What I draw inside it.
I mean, you should at least draw C8Cs, right? Right?
Yeah, but I need to draw it in like a shape, right? So
octagon?
Yeah, I don't know how to draw octagon.
You have a point, but you're close. Yeah, definitely. I mean, this is one possibility. Definitely. Not bad.
Mm, so it would be 1, 2, 3, 4. That's C8, H16, right?
That would be if it is close to cyclohexane, right? That's the maximum H you can have, right?
Yeah.
C8, H16. On the other extreme, you can have as little as how many H's? Double bonded.
None, I guess. None, I guess.
No. When you, I suppose if you double bond everything, if you double bond everything, you will have no H's at all, right? For some reason, that does not happen. And the reason was actually very clear. If you have the kit, you cannot double bond everything. With the kit, it's very easy to see. So right now, you can only accept the fact without the kit. You can only accept the fact that the double bond can only alternate with single bonds. Okay, you can only alternate with single bond. So you cannot double bond everything. So what is the minimum amount of H?
There's 1, 2, 3, 4.
Yeah, right.
So
4 double bonds.
4 double bonds take away 8. That would be
C8, H8. Yeah. So you write down C8, H8 or C8, H16, right? You write that both down. Both, which is not C8, H10. So back to the answer. Back to the question. How does it look like? C8, H10. What do you think it looks like? Is it really more like the benzene, or is it really more the cyclohexane, or is it more like in the middle?
In the middle.
Yep. So draw something possible, please, with for C8, H10. Draw something. At this point, you should be able to predict how many double bonds you need.
So we start at 16, right? So I need that is.
Yeah, so I'm not looking at what you're writing. That means I'm still not looking at anything that you're. Yeah, okay, there you go. Right. Something like that. I know it's not octagon, but who cares for it, right? So this is the possible C8H10. The other one is alkene with four double bonds.
Yeah.
Okay. So those are options. Options. So far, so good. Clear.
Right.
Right. Technically, I'm reasonably happy with the stand. We'll go back to the stand. We're doing a review of the stand. Are you happy with the stand and the setup and the light in the room, whatever?
I don't mind.
Any complaints? Yeah.
No, nothing wrong. It's just I was thinking of using this place, not like how should I do it? Let's see. It's like if this space doesn't work out, which is I'm kind of like on, I might just like move back to my room. I'll still use the light out, obviously, but like
the light is not enough. Is it?
The light's fine. It's just the
right.
It's just like the area is less ideal than I imagined it to be. In fact, speaking of less ideal, give me a second.
Right. So it's not the stand, it's not the table, it's the area.
Yeah.
Right. Feel free to do that. Yeah. Sorry. Right.
I'll think about it, and if I feel like it doesn't work out, then I'll move back to my room.
Correct.
And I'll just try to get rid of distractions one day.
Correct. We will work on that. We have to work on it, right? So today we stick on this place, just to be very sure, right? Then on Wednesday, maybe you can simply actually just try your room, right? Then we'll see what happens, right? Okay. Right. So, all right. So if the stand, no problem. We'll just continue first. Okay.
Yeah.
Okay. Right. So back to this. So at this point, we are actually just covering the basics of Arene. So Arene can be this, Arene can be that. And I promise you, if you play with the kit, you will understand why, right? Okay. So the homework is actually for you to make a benzene. That's the homework. To make a benzene. You don't have to make the cyclohexene. If you want to, that's also nice. let's see which one you will select, because remember back then we went through, different types of carbon, right? This one, that one, this one is sp3, this one is sp2, that kind of thing. Remember? Right. So let's see whether you can make or remake the benzene from your kit. So on Wednesday, we will immediately start with that kit. Fair enough? Okay, right. Now, at this point, we will enter deeper and deeper. That means we will look at the reaction list. The reaction list is the heart of the every OChem chapter. But I do notice that your next exam does not include arene. Right?
I think it's alkanes and alkenes.
Correct. So at this point,
after that, the next test will be 7. Then they will test like everything else.
Correct. But I mean, on the preparation principle, because we want to have a good study habit, right? Frankly speaking, it's very good. Suddenly your video is off. I cannot see anything. Yankin, can you hear me? 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 Okay. Currently, I'm not hearing you and I'm not seeing you. I cannot hear you and cannot see. Handphonenya mati. Handphonenya mati. Tadi dia les di bawah. Di bawah rumahnya. Dia kan kondom kan, si anjing.
Oh ya, anjing.
Dia mau coba di bawah rumahnya. Dia bilang coba aja. Mak. You don't like it, Abia? It is bad. Thank you, God. Oh, Daddy's holding you. Daddy has shit. Nggak tahu, Mama. Mama, aku perlu handover nih. Kasih Mama ya. Mau dipakai dulu? Oh, betul kan dia. Hahaha. Okay, hello Yankin, can you hear? Right. Okay, I'm seeing you, right? Okay. Everything more blurry, so the connection is not as good as just now, right? Right. So, better, yeah. To zoom in, maybe zoom out a bit, just a bit. Okay, one, yeah. Okay, that's fine. I suppose that's fine. Right. Okay. So, all right. Okay. So the stand comes with a long cable. Does it fit your handphone?
Yeah, it does.
All right. So maybe in your room you can pair it with a charger. Maybe that's nice, right? So good thinking on preparing two phones, right? Okay. Maybe a power bank. Now at this point, what I'm asking you is that for preparation purpose, let's say you want to do well in your this small exam, right? Then no point studying this first, no, because we'll go through the reaction list deeply, and you want to understand the reaction list, because if not, then no point. And right now, it may actually interfere with you understanding alkane and alkene, unless you feel very comfortable with them already. This can wait, is what I'm trying to say, if you want to wait, right?
Yeah, I think we can go through alkane to alkene.
Yeah, that's probably better for now. Okay, so if you want to, either you jump directly into some questions in alkene, or we go through the reaction list. I think either way we have to do lah.
Okay.
Yeah. When I say reaction list, I am assuming that in your lecture note, the last page, usually you will have a reaction list. Basically, a kind of like a summary kind of thing lah. Okay.
Yeah, I think I know what you're talking about.
Right. Okay, let's see. So let's see. Okay, great. Okay, so in this kind of page, I will have problems seeing everything, right? Okay, but you're zooming out for me, which is great, right? So hydrocarbon tutorial alkene, right? So it's not bad. I can see some details, right? That's nice. Yeah. This is basically. So I'm just seeing. Yeah. Yes. Obviously, yes. You have your alcohol, of course. Then you have your of course yeah, okay. And the last one is right, the addition of water, of course, to obviously make alcohol, right? Which is he differentiate that with okay, the last one I'm a bit confused. Why is that? Right, so this is a summary of alkene lah. This is a summary of alkene. Every chapter has this kind of summary. So if you memorize it, if you just memorize it only, you have to grind a lot. You have to grind a lot to even get it suitable for A level. You have to memorize like maybe 11 pages of this kind of thing, because there's a lot of or chem chapter. So when we can, we try our best to understand some. We have to memorize some, fair enough, but we can try our best to understand some so that we don't have to grind too much. That might be something good for you. At least that's what I feel, right? Unless you are good in memorizing, in which you should memorize immediately, like right now, you should. And I can tell you how to memorize very effectively, right? Now,
All right.
your choice. You know yourself. You know yourself. You spend time memorizing, or you spend time understanding so that memorizing less. Or you want a hybrid, I don't know. What is your self-knowledge here?
Spend time memorizing. Yes. I'm not so sure I want to spend like all the time memorizing like all this stuff.
Mm-hmm.
And like I don't even think my teacher taught it that way. That's like memorize it. She was like,
Mm-hmm.
it was more like you start from the center, then you start branching out.
Fair enough.
Then like you add different things and you figure out how they work with the alkene in the center.
Yeah. 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 So what you're saying is that you want to try your best to understand and then maybe memorize the rest, is what you're trying to say.
Yeah.
Right. So you should take the approach immediately for exam, like the upcoming exam, where you only have alkane, a very small summary, right? Very, very small, and alkene, which is yeah, this is about a sizable summary. This is about how the other chapters will look like, right? Yeah. Okay. So you have made the decision. What I'm trying to say is this, Yankin, this kind of thing, you decide from the start, like right now, oh, I want to understand. Then I want to see which one I need to memorize, which is hopefully, very little, right? You make this kind of decision at the start to not memorize everything, and then you stick to it. You don't swap in the middle. You don't. You try your best not to. You don't make a decision every time you encounter another chapter. Walama, this one I cannot understand, so I want to memorize. You don't do that. You simply understand the best you can. Okay. Okay. So I'll give you a few pointers on how to understand, and then let's see what you actually need to memorize. That will depend. That will vary from people to people. Okay. Ken? Yeah. Okay. Now, you're going to flip between the alkane and the alkene. Okay. So do you have the alkane summary page? Just flip it.
You mean the alkane summary page?
Yeah, there must be, because there's only a very small amount of alkane reaction, but hopefully it's there, just to make things clear.
Oh, it's a very long.
This is not alkane. This is like the intro. The alkane starts when you talk about the free radical substitution.
Oh yeah.
Around there. It is not a very complicated chart. See, look at the summary. Look at the summary. Look at the summary. Plus, combustion and everything. I'm going to ignore combustion and everything. The one below. Okay? Just going to ignore that for now. Look at the summary of alkane. It tells you that alkane is a very boring substance. Do you understand what I'm saying?
Yeah, I guess. Yeah.
There isn't much that you can do with it. There isn't much. Okay? Ken? That's the one thing I want you to notice. The second thing is, do you need to memorize incomplete combustion?
No, because like it can be. I say no because it can be like anything, right? Like.
But the incomplete combustion will always have limited O2 compared to the carbon, right? And it will always produce CO and some other thing. I suppose that's it. Whereas the complete combustion, do you notice that this page has a complete combustion?
Yeah.
No, I'm not talking about the the one to the which one do you point? No, on the summary, not on the one below here. No. Not on the one below here. I know this is complete combustion, but on top, the one on top, the one with only 4 branches. Like, do you notice that there's a complete combustion there? I am a bit bothered if you do not notice. That's a common question. So in complete combustion, you don't need to memorize. Complete combustion, you don't need to memorize. Do you feel safe declaring that to yourself?
Yeah, because we just feel too sure that you end
Right. So if you feel safe, would you please now decide on a sign right now with your pencil, a sign that says, this one I understand. Right? What kind of sign would you use, right? Okay. And you have a different sign for those that you think you need to memorize, right? So, okay, so you take, right? Then I would strongly suggest that you do not take the result. It doesn't make a lot of sense because a reaction is an understanding from the start, the middle to the end. Do you understand? A reaction is not the end. That's nonsense. That's nonsense, right? So you must at least understand the start, middle, and end, but you just use one tick look. Maybe the tick should be in the middle, is what I'm trying to say. Okay. You cannot just say, oh, complete combustion, CO2 plus H2O. No. From where, right? From where? Okay. What else can you tick? You know, hopefully you don't have to write the word understood every time. Hopefully, like.
Yeah, but I guess this is theoretical substitution, right?
The incomplete combustion first, if you can declare it understood.
I mean, I can.
Can you declare that right now? Until forever, I basically understood incomplete combustion. Right. Okay. Now, regarding the other two, right? There's only two other reactions, right? Okay. Notice that the arrow matters, lah. Notice that the arrow goes from alkane to halogenoalkane, whatever that fancy word is. Right? Notice that the arrow doesn't go two ways. Notice that. Okay. Also notice that from alkene to alkane, the arrow is different, right? The arrow is different. One goes in, one goes out, so to speak.
It's like a dotted line.
Yeah. The dotted line has some question to it, but it's not very difficult to understand. Really, it's not. You will understand it in the alkene chapter. My point is, before anything, you may want to notice the direction of the arrow. You may. It's not the result, you know. You'll be very confused if you memorize or try to understand in terms of result only. Right? Then you get very confused. What changes to what? Right? For example, in the lower reaction, if you just say, oh, it's alkane and alkene, but you don't even remember or make sense what the direction of the arrow, why is the direction arrow like that? Then you don't understand the reaction at all. You don't. Okay? You don't, yeah? Warn you first. Can yeah? Now, which one do you feel is easier to understand right now? If you have a preference, like the top one or the bottom one?
Which one is easier to understand?
If both is hard, then I'll give you tips immediately.
I mean, the mechanism for theoretical substitution is so that.
Yeah. What bothers me about this summary is that I don't notice any mechanism for the top one. That does bother me a bit. Or rather, maybe you're supposed to fill that in. I don't know.
Oh, I guess I just didn't.
All right.
Like when I do tutorial, I just keep the substitution.
Right. So right now I'm asking you, you notice that the alkene chapter discusses a few things and then they discuss it in very great detail, right? One of them is free radical substitution, right? And the tutorial will kind of drill you down on whether you can spell out free radical substitution, right?
Yep.
My question is there any free radical substitution here? Oh, this bothers me a lot. Oh,
I
you cannot answer.
to be that there is, right?
But are you doubting yourself? Or are you just waiting for confirmation? You know the answer already, or you really don't see it?
I mean,
or you have to think first.
It seems pretty obvious that it's there, but like now that you ask the question,
You cannot see it.
I mean, I can. It's like
Where?
it's
Which
there.
one?
You know the scale.
Which one?
Like,
Which one is
Like-
free radical substitution?
Hello.
Good. If you can see it, finish. No, that. You understand it? That. The upward reaction is free radical substitution. That,
Yeah.
Right. So it depends on how much you understand free radical substitution rather than simply memorizing this. And the way the lecture note and the tutorial kind of presented to you that it is somehow important to understand it in detail. If you cannot, then you remember it in detail, whichever you wish. Okay. I'm talking about the 3 steps, you know, the blah, 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 propagation, this termination, those kind of stuff, right? Okay.
All right.
So done. So how can you declare this free radical substitution? Can you declare that you understood, or do you declare that you better understand free radical substitution, or how do you declare this?
I mean, I guess I'll take it.
Yeah, go ahead, take it. Any other notes?
What do you mean? Any other?
Do you want to write anything else?
I guess I'll just make it sure that the equals understood.
Right. So 1 month from now, 2 months from now, you look at this thing. Would you wonder, hey, how come I say I understand this?
Not. I mean, I can still, if I can still remember it from like I learned it around like October. So
Right.
if I can still remember it now, I hope not. I
Right.
hope that I can still remember pretty much of it.
So free radical substitution done, right? Okay, done. Right. So now only the bottom one remains lah, out of this alkene, right? The bottom one, this catalyst, heat, or blah, 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 RTP reduction from alkene to alkane. I want you to immediately compare with the summary page of alkene.
Okay.
Right. So you're going to flip between them and compare whether there's anything comparable.
So no.
So you already know, or did you realize that before? Or
I mean, it was pretty obvious.
right, so
Yeah,
done. So
okay.
now your decision is on this.
I mean,
it's very similar reaction.
yeah, reduction is just like it's just taking away the double bond, isn't it? Saying like H2.
Yeah, but how do you take away the double?
You add H2 gas.
Very good. The word is either reduction or addition of H2 lah. Either one, right? Addition of H2, right? So which is comparable to addition of which is some ways comparable to the electrophilic addition. Some ways lah. It is still addition lah. Is what I'm trying to say.
All right.
Which is also comparable to the addition of H2O. Also comparable. Am I making it?
Yeah.
So when you take away double bond, you can add H and H. There you go. Or you can add BR-BR, right? Electrophilic addition. Or you can add OH and H, which is, you know, you will get your alcohol. That one, that guy. I consider them kind of similar. They're not exactly the same, but that's how you take away the double bond. You add stuff, basically. Basically.
Okay.
So there is electrophilic addition of HCl. Wait a minute, that's not very different from adding, well, H and Cl. Oh, they are all taking away the double bond in a way that you add something to it. In a way, right? Something.
But the mechanism is different.
Slightly different. That's why some people will prefer to call the addition of H2 reduction, and some people will really emphasize on the fact that BR-BR is electrophilic. They do drill down on this. Fair enough. Fair enough. Right. So now, are you ready to take a bit more? Like going back to the alkane, is it okay to take, or is it like maybe you have to say I need to memorize this part, that kind of thing? There are things to memorize, unfortunately. So you have to. Right. So what is your sign for memorizing? So that next time you flip to this page, I'm going to memorize this. That. What is your sign? I would usually use a different color, maybe red, maybe I won't highlight. I think highlight is for important stuff. I think I will assign it slightly differently, but you do need to make it very clear that I will memorize this, like this thing, right? Maybe I will use two. I will use two. It's so difficult to it's so difficult to show you things without my own screen, right?
I can just swap your screen.
Yeah, I will do that. Right. So yeah. So you just stand a bit, right? Just stand a bit. I'm going to show you my screen, right? So let's do that, right? So I'm going to share my screen. Just stand a bit for me. You don't. Oh, you're flipping it to your side. Okay, that makes sense.
Right? Yeah.
Makes sense. So you're just seeing my screen right now. Please wait for a while. Okay, what I will do, you see my screen, right? What I will do is maybe something like this. Using a red color, I will do that. Something like that. That's one way to indicate that, okay, I will memorize this, one day before exam, no point memorizing it 1 week before exam. No point. Okay. So if you like this kind of marking, then you do that every time.
Yeah, I guess I could do that.
Right. Okay. So I'll stop my sharing again because the connection deteriorates kind of noticeably. Okay. So if you like it, please do that. This whole thing I will memorize. Right. Okay. So done. Finish. Right. Anything else about the alkane that you think you have to either understand or memorize?
Not really. I mean, alkanes are kind of simple, I think.
Right. Sure thing. Now go back to alkene. So now we start with alkene. Right. Start with alkene.
Oh.
If there are ticks already and there are things that you need to memorize already, immediately do that, right? Immediately do that. Okay. Or additional notes you want to add so that you can understand it next time, nothing. And let's see what remains. No possible ticks right now. Is there any possible ticks so far?
Let me think. Yeah. I mean, like, I kind of know how electrophilic addition works, but like,
is that a tick? Is that a tick?
I have to test myself before
like when you understand it, you can forget. Okay. What I'm trying to say is when you understand it, you will quickly revise it next time. But my point is, it is something to understand, not to memorize. Kind of, maybe, just to be a bit general about it.
Yeah, I think electrophilic addition, I'll understand it. Right. There's like a root with everything, right? So it's like,
correct. I mean, they really focus on that, right?
I can apply it to any situation.
Yeah. You can apply to question, if they ask you something about it, you understand. You do understand what's Markovnikov rule, that kind of thing, right? So all electrophilic addition or just this particular HCl? Like which one? Like there's an electrophilic addition of Br2, right?
I mean,
in water, and there's an electrophilic addition of Br2 in CCl in organic organic solvent, that kind of thing, right? Correct?
And they pretty much the same thing.
But one is aqueous, one is not, lah.
That's true.
Right? You do need to know why they are telling you this, because if you do it in aqueous, you will get that. If you do it in a non-aqueous solvent, then you will get this. That's
how they do it with water being more like.
Sorry. What?
I'm trying to remember what the difference is.
You can look at the note immediately, right? You can look at your notes immediately. Like that is not that is, I mean, unless you decide to memorize that. No, I don't think you want to memorize that. Yeah, I don't think so. Right. So inert solvent, right? This one, inert solvent, right? Okay. Then the next page will be the aqueous Br2 lah. Right. So you read. There's nothing much else here but to read. If you want to ask something, please go ahead.
No, I don't think there's much difference, is there?
Except that you have to be able to describe the difference. You still have to describe. The step one, maybe Maybe that's what you mean by the step 1 is not very different. What?
Yeah.
In fact, the step 1 is
Standard.
probably the same, probably, if you compare them. The difference must be in, you check it out, lah. Step 1, step 2, you know. Is it correct? Step 1 is the same, but step 2 is different. You don't have to flip here, no.
Okay, wait. What H2O is this, right? This equals, right?
Yeah. No, this is already more complicated. No, this is already more complicated. This is what if another species, well, no, I'm sorry. No, you're right. Sorry, I'm sorry. This is your,
Like,
this is your,
doing
yeah,
the
I'm
equals
sorry.
one, right?
Yeah, I'm sorry.
Yeah, it has to do with water, right? It's like water.
Yeah,
like,
sorry. Obviously, you're correct. Sorry. This one.
One of the
right.
all the parts. Yeah, okay.
And they did explain this again. Yeah, see. So you still have the first step, right? You still have the first step here, right? Equals BR2. Look at the first step. The first step is exactly the same, I believe. Right?
But then the water.
Then the second step will be different. So the first step is always the formation of the carbocation, whatever that means, that carbocation. And that is where you first have the electrophile addition, basically. That's the first step. Right? So first step is the same, second step is different.
Because the water will bond with it, then. Yeah.
And why is water, major? Why is the BR minor?
It's a solvent, right?
So it is a volume thingy, I'm present in larger quantity. Kind of fair. So that's why it's a major problem. Okay, fair. Nothing to do with rules or something. Okay. Do you feel that one day before exam you can understand this quickly by simply revising for a while?
I think so.
All right. Then are you ready to take?
Sure.
So take. Right. And therefore, I believe the electrophilation on top also you want to take. That's the right.
There's no difference. I don't believe.
Right.
Yeah. So.
Yeah, that's the one with. Right. Anything else to take before we start to either memorize or understand?
Anything else to understand? H2O. I mean, oxidative cleavage, I think I can understand.
Right. Tell me the oxidation part, right? So the moment you so let me just give you a very brief. So let me just say that the KMNO4 will appear a lot in other chapters. So oxidation by they will call it strong oxidation, right? Strong oxidation by hot KMNO4, blah blah blah, this kind of thing, heat under reflux. So it's a strong one, appears a lot in other chapters. The mild one, very simple difference, right? It's cold, so less heat appears less, so the strong one. But in general, oxidation is a big thing, right? So as much as possible, we try to understand it, because if not, then there'll be too much to memorize. Please tell me why oxidation here is oxidation, and why the top guy is reduction. Why are they oxidation and reduction? Do you know why?
I mean, one of them is I mean, I don't want to one of them is like adding
H.
oxygen, the other one's like adding hydrogen. So it's like,
So I suppose adding oxygen is oxidation and adding H is reduction, right?
reduction. Yeah.
You're absolutely correct. Now, I just want to make it clear at the risk of our time is done. No, let's finish this. Right. At the risk of complicating the subject, if it does not, then it's your benefit. So please look at my screen for a while. Yes, one more. Right, so here's alkene, right? So I'll do a very quick comparison with you. So I'm focusing on the oxidation number of the C.
I don't think it's a screen there.
I'm so sorry, I haven't shared, right? So I'm focusing on the oxidation number of the C. The H and the O is always, always -2 and +1, correct? Okay, so for CO2, obviously the O is -2, right? That's obvious, right?
Yeah.
Right, so this is +4. The C here is +4. Okay. That's the highest oxidation number obtainable by a C, highest. Okay.
Yeah.
Now, in comparison, there is no CH4 here, but I am going to draw CH4. In comparison, CH4, what's the oxidation number of C here?
+4, right?
No, -4. Right, no.
Really? I thought the H can be
+1. H is +1, right?
No, I've read before that the H can be -1 as well. So
but oh my goodness. No, obviously you're correct. No, obviously you're correct. However, O is -2. Why is O -2? You learn in the orbital part, which is basically semester 1. You learn that O is the second greediest factor, right? So the O -2 is representing the O taking the C's share of the electron, right? That's -2. So C +4 is representing his all 4 electron is, so to speak, being taken away by O. The sharing is unequal. It's the unequal sharing thing, right? Okay.
Yeah.
Which is the force of dipole. Now H, even though H can be +1 and -1, H is rarely -1. H is very frequently +1. That means he will gladly give his share to other people most of the time. That's basically what it means. He's almost guaranteed +1. He's only -1 when you pair it with metal, which is not the case here. Simple. Okay. Can you? So C in CH4 is -4 because H is, donating his electron to C all the way. Okay. So far so good.
All right. Okay. I guess that.
Right. So now let's focus on the oxidation number of the alkane, and in this case carboxylic acid. When I say carboxylic acid, do you know who am I talking about?
Isn't it the CO2H2?
No, this is COH. This is the part where they say carb.
COH, yeah. Okay.
It's the weird guy, but the weird guy is very distinctive, It's very distinctive. So let's focus on the 3 things. So first, I'll focus on the alkene. Notice that this alkene is obviously -3, right? Notice that this is -3. Right. It's very simple to see, right? Because it has 3 H's, right? And this C is, well, a -1, right? -1. And then this C is obviously -2, right? Okay. So now this is -3, this one. Notice that the CH3 is always -3, right? Okay, this also -3. So what we are saying is that this CH3 basically is not, is barely touched, just consider it untouched. Okay.
All right.
Now, but the CH2 and the CH3 here is obviously now reduced. Obviously, it is being reduced. You can see the reduction almost immediately, right? So that's why adding the H is adding the H is, you're adding somebody who is willing to donate his electron. That's why the C experience reduction. It's very obvious. So this is one layer of understanding that you can add. That's why reduction is adding H. You're adding a donor, right? So you become more negative. Look, okay. Now, when you oxidize, you're adding oxygen. So you're adding somebody who will take away your electron. So it's being oxidized. Simple, right? Now let's see that in action. Let's see that in action. So the strong oxidation, look at this C. This C, well, how many oxidation number is he?
That one is we want to connected to O and OH. So it's
Don't forget it's OH. Don't forget. So it is
OH minus and O2 minus. Isn't that plus 3?
Plus how many? Plus 3. Yeah, correct. Because minus 2 from this O, right? And then OH
1
will be minus 1. So this is plus 3, right? Plus 3.
Yeah.
You can see why they call it strong oxidation. Look at what happened, like the affected C, one become plus 3, one become plus 4. The CO2 is the maximum. Like you see why already. Very easy to see. Okay. So look at the mild oxidation. Again, the mild oxidation is obviously affected by the OH. OH is another option, right? So OH is like, the OH itself is minus 1, right? So if the OH is minus 1, the C will become like plus 1, no? Something like that. You see why OH, adding an OH is like an oxidation kind of thing. You see why? It's slightly milder than adding an O. Again, you can see why. Correct or not?
Okay.
Right. So again, this is still minus 3, right? So the CH3 is like almost untouched. But this C, how many oxidation number is this?
So it has 1 H and 1 OH. So that's
right. So basically, that's
so it'll be plus 2.
Minus
1 plus 1. So it's
no, it's 0. It's 0. It's
minus
0.
1 plus 1 is 0.
Yeah, 0. So which is still an oxidation, but mild, right? Because you go from minus 1.
Then from minus 1 to 0.
Correct. So then the other guy, no?
C and 2 H's, that's plus 1.
Plus 1 minus 2.
Minus 1.
So minus 1. No, minus 1. Minus 1.
Really? Why is plus?
Because the H's cause you to minus 2.
Really?
Because the H is a plasma, so it causes the C to minus. Hello.
Oh yeah.
Right, CH4. That's why I go from CH4. CH4, the H is plasma, so the C is minus 1. Right. Can you remember? Because look, H is a donator of electron. He donates the electron to you. That's how you remember it, right? It's very good.
Then you become more negative, yeah.
You can more negative minus 2, but the OH will take away one of your electron, basically, right? One of them. So you minus 1. Still a mild oxidation from the alkene.
Minus 2 to minus 1, yeah.
You can see that very clearly. This is not clear-cut chemistry, but this is one way to see it. That's why there's a reason why they don't teach it clearly this way, because it's not actually clear that it is minus 1, minus 2, but you can kind of see the effect if you do this very rough. It's very rough chemistry, I just say. Okay. Now, does this help you?
I think so.
Right. Then.
Right.
So I'll send this to you because time's up, right? Send this to you. You do something, and then you decide for yourself whether this is half memorize, half understand, or you understand, or you have to memorize. You decide. Okay. Send it to you. Now time is up. Time is up. Do you have your study plan for tomorrow?
Yeah, I think so.
Right. And do you have study plan for Wednesday before we meet?
I should be making it tonight.
Right. Then you do you first. I won't ask you to discuss your study plan with me first. Right? You just do you. Okay. So for today, we basically simply test our gear, test the new space. You may like it, you may don't like it. And then we discuss chemistry in depth. This is about as in depth as we would need to go, right? Because then we need to apply it. Okay.
All right.
Right. Then I'll see you on Wednesday. Maybe you can test your room, and then we'll just continue. Okay.
All right.
Any other comments from you for today?
No, I don't think so.
All right.
I think I'll just have to like come in with like a better plan next time, you know.
Mhm. If you allow us to discuss your plan in detail, we shall do so. How to plan? We discuss, you try, see whether it works for you. Does it build a good habit for you next time? That is what I feel I can contribute. Not so much, the chemistry and the physics and math knowledge is important. I think the habit is at least equal to all that, I feel.
Right.
How you study it. So if you like, we'll start discussing a bit of that detail on Wednesday. Okay? Until then, I'll see you on Wednesday. Okay. Bye, Yankin.
I'm gonna go now.
All right.
Bye.
See? So, bye.